Multicollinearity. This is the concept which we are going to discuss in this video, and how I have made these slides using R that I will show you at the end of the video. Okay, what is concept of multicollinearity? When we say we have classical linear regression model, we assume that x1, x2, xk are neither perfectly correlated nor they are very highly correlated, but they should be correlated. If they are not correlated, then it does not make any sense to include all these variables in one model. Then there is no concept of Frisch-Wald theorem, anything else. So they should not be perfect correlation. They should not be very high correlation. What's the purpose? If our purpose is forecasting or prediction of y, then multicollinearity is not a serious issue, because it's all right hand side variables which play a collective role in predicting or forecasting y. If purpose is to measure the impact of x1, holding the effect of others constant, then it's important that x1 effect from x2 and other variables should be disentangled, should be separated. Third thing, multicollinearity is a data problem. It's basically some issues. You measure variable wrongly, you have some dummy variables more than desired, or some other you see calculation issue that you have included percentages of that variable and at the same time fraction of that variables. So this all leads to perfect multicollinearity and other issues. So what are the consequences of multicollinearity? Your estimators are still best linear unbiased, but what do you mean by best? There is no small magnitude in absolute sense. You can have a very large magnitude of variance, but still it's best. It will lead to low, high standard errors, low t-values, insignificant t-values. High R-square, but not very meaningful. Results are very, as I'm saying, that the results may not be significantly different from zero, which means you are not rejecting H0 when it should be. So regression, and lastly, that your coefficients will be very sensitive to small changes. Maybe one observation you add or one variable you drop, it changes your results drastically. Okay, so there is a term called variance inflation factor. So variance of beta 1 hat is sigma square this 1 over 1 minus r square is called variance inflation factor. How do we detect that there is multicollinearity? You see high R square, very low, few significant T ratios, pairwise correlations are very high, and if variance inflation factor as per Green econometric analysis greater than 20, and some other research suggests that if it is greater than 10, there is a multicollinearity. Okay, now we are going to test it empirically. I shall show you its scores. We have Longley data, which is widely used to demonstrate the concept of multicollinearity. We have 16 years data. In the first column, we have only we have excluded 1962, so 15 years data. In the second column, we have 16 years data. So you see, just by including one observation, 1962 here, your coefficients magnitude change by a large magnitude. This intercept, then you see year coefficient, there is a maybe 400-500% reduction here in price coefficient, and 600% reduction in your armed force coefficient. So you see, by including only one observation or by dropping one observation, most of your results become coefficients change by a large magnitude. So your R square is still very high, and this is how you can do it. Variance inflation factor for all this is, you see, very high variance inflation factor. All these variance inflation factors are greater than 20, greater than 10 as well. Okay, let's see last one, how to resolve the problem of multicollinearity. obtain more data, but easier said than done. If you have more data, then why you haven't used it at first stage? Obtain more information, it does not mean more data, it means you should get more information about the phenomena under study. That's very very useful. Bias and variance trade-off, there is, if you include extra variable or exclude relevant variable, there will be bias variance trade-off. Watch my video, inclusion and exclusion of relevant and irrelevant variables. Main remedy is force, theory and data. To resolve the problem of multicollinearity, please decide on the basis of your economic theory rather than going for technical solutions. Principal component is another tool, but be careful when you combine different variables to make a single variable, because many a times they don't have any economic interpretation. For example, how do we interpret the price elasticity minus twice the income elasticity? And finally, as I mentioned, how I have made these slides. Let's go. I click here in front of you, and we reach to R markdown. So you see, I have written this concept of multicollinearity, and all these bullets. You see, Longley data, I have uploaded library. So you see here, you don't have 1962, and in the second column you have 1962 whole data, and then we have variance inflation factor measured here, and these columns, and what are the strategies to resolve, and then I just need it to slidey. I get these slides. That's how we work with R for making slides, for doing analysis, for doing for making our document. Everything you can do it, and I can publish it by clicking on publish. Thank you for watching. Take care.